Only 1.4 billion people have no access to clean fresh water. The situation in Africa is much more critical. In Africa it can be 4 miles to reach water source. Africa is considered from the most arid continent. African deserts make up more than 25% of the geography in Africa. Mention the oldest desert in the world. The Namib Desert. The Namib stretches for more than 2,000 kilometers along the Atlantic coasts of Angola, Namibia, and South Africa. It has less than 10 millimeters of rain annually. Complete aridity is the best description for this desert. Obviously life here is too difficult. But the Pioneers team has another opinion.
Based on the nature of the desert, the climate and daily fog current, Namibia desert beetle technique. 2 engineers from Ain Shams University came up with a new integrated solution, which will bring life to Namibia. Based on hybrid approaches of solar and wind energy with special designing which is used for water desalination and producing electricity that may exceed 1 gigawatt, depending on optimum selection of each unit. All approaches present in our solution is 100% green and eco-friendly as no CO2 emissions is produced. Moreover, some approaches get use of natural phenomena as natural fog which contains high amount of water vapor which can be condensed for people's sake. Now let's see what we have here. Solar power towers generate electric power from sunlight by focusing concentrated solar radiation on a tower-mounted heat exchanger, receiver. The system uses hundreds to thousands of sun-tracking mirrors called heliostats to reflect the incident sunlight onto the receiver. These plants are best suited for utility-scale applications in the 30 to 400 megawatt range. Heat transfer fluid, HTF, is heated as it circulates through the receiver and returns to a series of heat exchangers in the power block where the fluid is used to generate high-pressure superheated steam. The whole process of producing superheated steam is shown in this diagram here. The superheated steam is then fed to a conventional reheat steam generator to produce electricity. A small portion of the spent steam from the turbine is condensed in a standard condenser and returned to the heat exchangers via condensate and feed water pumps to be transformed back into steam. While large portion of the spent steam is stored at a cooled tank as a desalinated water for human use. The pyramid surfaces that face the sun are covered by photovoltaic cells and the other surfaces are covered by a high thermal conductivity coefficient as to be fast cooled for condensing water vapor at dawn. If we look deeper into the pyramid we can see the tank where desalinated water from the condenser chamber or the residual water from the process of steam producing. The condenser chamber where the steam is condensed. The chiller to optimize the temperature of the tank and the whole isolating internal layer of the pyramid. The cover of the tank to keep it clean and protect it from insects, sand and impurities. The batteries, inverter, controllers and other switchgear for the electrical system which will provide the whole area with electrical power. The isolating internal layer of the pyramid which made of ceramic or mud to keep the previous components' temperature constant regardless the variations of the weather. There are an external pipe system that is fed by a pump that circulates cold ocean water under PV arrays for cooling purposes and raising this pipe's temperature slightly as then it passes by free cell collectors in order to be evaporated then superheated to enter the steam turbine eventually. And to achieve the maximum benefit from the sun's heat to produce steam, the free cell reflectors are used in our solution. In the free cell reflectors concentrate beam radiation to a stationary receiver at several meters height. This receiver contains a second stage reflector that directs all incoming rays to a tubular absorber. The mirrors themselves, each having a width of 0.5 meters, are not completely flat but have a very small curvature, which is achieved by mechanical bending. It helps here in getting water preheated then evaporated making it ready for superheating stage by the solar tower. Steam can reach above 100 degrees Celsius by free cell reflectors then reaching 270 degrees Celsius or 500 degrees Celsius by solar tower. Since there is a newly discovered water source could supply half of Africa's driest sub-Saharan country with 400 years of water, the new aquifer flows under the border between Angola and Namibia, covering an area of about 43 miles by 25 miles on Namibia's side. The water is up to 10,000 years old and cleaner to drink than many modern sources. Therefore a submersible pump shall be present to get advantage of this great water source as extracted water shall be pumped to the storage tank or even stored separately if it more qualified than the desalinated water. Combining the concept of wind energy in our solution maintain many advantages. The most important one is producing electricity not only on sun peak hours, which means not depending on solar approaches only, but this hybridized RTO allows electricity generation at night as well. Offshore wind turbines may replace onshore ones as for the great advantages of the first, if optimum design is found and is cost effective. Now let's see how it works. The wind farm operates as a hood to create a low pressure area to collect the dew. Pump withdraw cold ocean water below 9 degrees Celsius, allowing it to circulate under PV panels, so it cools it down. Hence dew is formed on its surface resulting from the enormous fog present at the early morning. Water is then collected through pipes and stored at the tank eventually, while circulated water is pumped back at low flow back to the ocean. At noon, main idea is to evaporate water into superheated steam suitable for operating the steam turbine. This is done by three means. Firstly, relatively hot water ejected after cooling the PV panels, around 30 degrees Celsius, is then evaporated to steam through CSP mirrors present along pipe length till entering the tower for superheating stage. Secondly, heliostats collect incident solar radiation then reflects it back to the receiver at the top of the tower. This energy is used to heat oil, heat transfer fluid, then through a heat exchanger the heat is then transferred to water pipe providing a superheating for the steam. Thirdly, normal solar radiation falling on the tower as both oil and steam pipes are considered to be on the outer surface of the tower. After gaining required superheated steam temperature for operating steam turbines, 270 or 500 degrees Celsius, the steam exiting the turbine is then condensed in the condensation chamber and finally water is stored in the cold tank maintaining its temperature 20 degrees Celsius or less by the aid of the chillers. Also the wind farm operates as generator for the electricity at this time. at night. Main aim at night is to prepare the pyramid for the dawn by cooling it down such that maximum amount of dew is formed on its surface, hence more amount of water is gained. This is done by two means. Firstly, pump will withdraw ocean water, below 9 degrees Celsius, and two-way valve is operated such that water is circulated on both the external and internal pyramid surfaces, cooling them down, then water is pumped at low flow back to the ocean. Secondly, chillers is operated near the dawn time, if necessary, for gaining the required low temperature needed for dew formation. Although this desert considered from the most arid places in the world, but its geography and tough climate represent the key for this solution. Talking about the solar energy. The solar radiation on Namibia's coast ranges between 2400 and 2500 kilowatt-hour per square meters and even more. So solar energy is most probably the best renewable energy approach used here. Therefore, our solution contains an integrated collection between different solar technologies like PV, CSP and solar water desalination techniques. Also, the frequent fog current across the coast play a very effective role in the water harvesting process. As the whole coast of Namibia has more than 125 days of fog per year, we can ensure the existence of the desalinated water from this natural phenomena most of the year, which means lower dependability on electricity for getting water heated and then condensed. Not to mention, the newly discovered groundwater in the north of Namib. In summary, water, electricity and air pollution reduction are considered the world's most ongoing demands, especially in Namibia. This solution will be a clean source of a pure desalinated water as well as green renewable energies for the sake of Namibian people. Generally, this solution will be the core of the development in Africa, which needs more care from the world. This is our vision. This is the center of life.